All right, good afternoon, everybody. It looks like there's only 5 of you right now, so this might be a quick class here for us. Somewhat quick anyways. I know you guys only had a couple of questions. So let me talk a little bit about 3-4 to start with. And then I'll talk about 3-5 once we move on to that question. And let me talk about 3-4, and then I'll kind of talk about the overview of everything here. Maybe we'll have a few more people on by that time. So for 3-4, this is on finding the roots of polynomials. And the way that we do that is if we're given a polynomial and it's an x to the n plus a bunch of stuff and then some constant a to the 0, a of 0 at the end, the polynomial has rational roots of the form p over q, where p is a factor of a0. So if the constant at the end is 6, then we're going to use plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 as the values for p. And then q is the factors of a sub n. So if this is just a leading coefficient of 1, it's going to be only plus or minus 1. So the combination would be all the factors of a0 over all the factors of a sub n. And so when we're trying to find these, we're going to use synthetic division to figure out what the factors are. But we can help ourselves out a little bit. I know some instructors don't teach this sign change rule, but I think it's useful because it kind of leads you down like, all right, should I find the positive roots or should I find the negative roots first in order to save you a lot of wasted time? And so what the sign change rule says is that if I take my polynomial, so let's look at an example here. Let's say we have a piece of x is 2x squared, 2x to the third minus x squared plus x plus 1, let's say. So piece of x tells us that if we look at how many times the sign changes from when we start to when we end, that's the number of possible positive roots or less by 2s. So let's say I calculated the number of sign changes and it was 6 sign changes. Well, then it would be 6 or 4 or 2 or 0. I keep decreasing by 2s until I hit 0 or 1. Or let's say that it was 9. So if I had some huge polynomial and there was 9 sign changes, then it would be 9 or 7 or 5 or 3 or 1. You keep decreasing by 2, and those are the possible number of roots, either positive or negative. The negatives come in when we plug in negative x into this polynomial. But the shortcut is really wherever I have an odd exponent, so 3 and 1, those are the only exponents I change. Because if I plug in negative x and then I square it, well, negative squared becomes a positive. And any even exponent is going to do that. So for this polynomial, the only one that's going to change is this. So this becomes minus 2x to the third. Leave this one alone. This becomes minus x, and then leave the constant alone. The constant's never going to change. So now we have what? We start with negative, we stay negative, switches to positive. So we only have one possible negative root for this polynomial. So that's the way that the sign change works. So what did I say the first one was? 1, 2. Yeah, so the first one was either, what was it, 2 or 0? Yeah. And for the negative roots, it's only 1. So if I was working this problem, I would try to find the negative roots first because there's only one of them. So as soon as I find that root, that's it, I'm done. I don't have to check all the other combinations. So that's why this sign change rule can save you a little bit of time. So any questions on that? Anything from 3-4 before I get into, again, some administrative stuff I want to deal with before we get into working problems here today? So any questions on anything from 3-4? Finding the roots, sign change, figuring out what the possible roots are, any of that. Okay, so what I want to talk about then, and I know there's only like 8 of you, but so be it. You guys get to hear it and the rest don't. So first of all, you should now be able to view your exam 2. The last class, they said that they could see it. I went in and fixed the settings that still needed to be fixed. And so hopefully now you guys are able to see your exam 2. Exam 3 is coming up somewhat in a hurry on us here. So we have this week of material. We have next week where we're going to be looking at material, and then that's it. Then we're done with the semester for material. So let's see, 1, 2. So 2 weeks from today will be a review day. And then 2 weeks from Wednesday will be your, is that right? 2 weeks, 15, 20? Yeah. So 2 weeks from Wednesday will be your exam 3, April 29th. And so I will start putting together the list. I have to write the test, so I'll probably do that this weekend. It's a little bit time consuming with this new method. That's okay. So I'll probably do that this weekend. And so next Monday, I can give you guys an idea exactly what's going to be on exam 3, so you can start preparing for that. In addition, I'll probably start a thread on Canvas with the concept questions so that you guys can start working on those as well. This exam, there's not going to be 17 or 20, however many there was, concept questions, maybe a handful, 10, 5 to 10, something like that, I'm guessing. And then the rest will be problems that you have to work out, ideally trying to get you ready for the final exam. Because then as soon as your exam 3 is done, we have review week and then the final. So as soon as, basically a week after you take exam 3, you get your final exam. That's Saturday, May 9th. So it'll all be coming up on us on a hurry here. So that's it as far as that goes. So the last thing I want to talk about, I got several emails over the weekend. I didn't reply to any of them because I just want to kind of talk to you guys about it here. But a lot of people were asking me, so I'm assuming you guys are signing up for classes. People were asking, what's my schedule for the fall or summer? And in part, I didn't reply because the answer is I don't know. They typically do not assign courses for the fall until like August, early August, maybe mid-August. I don't know with this whole coronavirus thing. I mean, obviously everything is behind schedule now, and I don't know how that's going to affect scheduling for the summer and especially for the fall. But what I can tell you is this. So if you are signing up for classes, if you want me, okay, great. If you don't want to take me again, that's fine. At least you'll know. So here is what I'm going to request. And they're usually pretty good about giving us what we request for our schedule. Again, there's no guarantees, but they usually send out an email saying, okay, what classes do you want to teach? What days, what times, what sections, etc. So for Math 127, I will be requesting section 1009 and 1011. So Jonna, in the ideal world, it will be the exact same. So the reason I set up my schedule this way is that my Math 127 classes are Tuesday and Thursday at 8:30 and Tuesday and Thursday at 10 a.m. So 8:30 a.m. and 10 a.m. The reason I do this is that way I'm done by Thursdays at 11:30, and then I don't have to teach again until Mondays at 1. So I basically get a 4-day weekend every week. So I always ask for the same schedule, and for the last couple of years, they've been pretty good about giving it to me. So again, these are the classes, the sections that I will be requesting. Whether or not they give them to me is, up to them. But for the fall, and this is fall 2020. So again, if you want to take me for 127, sign up for one of those sections. And I know, I will send you guys an email saying, hey, the department just told me I'm teaching these, you're good to go. Or the department just told me I'm teaching these sections instead. If you want to switch, you'll have to switch. But if you guys are signing up for classes right now, these would be the ones that you would want to sign up for the fall anyhow. And then as far as summer classes go, I don't even know how that's working yet. So again, they haven't sent out an email asking who wants to teach summer classes. It would probably depend what's available and what times. Historically, I don't teach summer. I taught summer class summer of 2013. And that was the only time that I ever taught summer. I just like having my summers off. So I haven't taught summer usually. But with this coronavirus, the extra money over the summer might be nice. And so maybe I'll teach over the summer this year. But as of this point, I don't know. But similarly, as soon as I know anything, then I will, let you guys know right away. So at least you guys are the first ones to know. So that's it as far as Math 127 goes. So any questions on that? My schedule, at least as much as I know or can predict. All right. So then let's get into the questions you guys had for this section, 3.4 and 3.5. So 3.4, this was the finding the roots. And the questions you guys had was 8 and 9. And this was on the sign change rule. And it does get a little bit confusing. So let me kind of go through these. We'll go through 8 together, and then I'll let you guys try 9 on your own. So 8, we have 3x to the third minus 8x squared plus 4x minus 3. So the first thing it asks us is how many possible positive roots do we have? So again, to figure this out, we look at what do we start with? Well, this is a positive coefficient. It then switches to negative, that's 1. Switches back to positive, that's 2. Switches to negative again, 3. So the sign changed 3 times, positive to negative to positive to negative. So the possible positive is either 3 or we have to decrease by increments of 2. So there's either 3 possible positive roots or there's 1 positive root. That's what the sign change tells us. Does that make sense to that point? So then next, so this was P of x. So P of minus x, again, it's only the terms that have an odd exponent. Those are the only ones that change the sign. So this was positive, so it becomes minus 3x to the third. This one stays the same. This was plus 4x, so it's now minus 4x. And this one stays the same. So then how many sign changes do I have here? I start with negative, it stays negative, stays negative, stays negative. So the answer is it never changes. There is no sign change. So therefore, the possible negative roots is 0. If I was to figure out the roots of this guy, there aren't any negative roots. And that's why I said this sign change can really help me, because if I'm going to be doing synthetic division, I don't want to test any of the possible negative roots because I know there aren't any. I'm just wasting my time. So if I tried -1 and -3, I know that those aren't even possibilities because there aren't any negative ones. So then the last box, and this is the tricky one, says what's the number of real roots? Well, I know there's 0 negative roots. So the only number of real roots I can have is either 3 or 1. It can't be 0 because I know there has to be at least 3 or 1. And so then the total number of real has to also be either 3 or 1. And I know that if there is 3 or 1, they're both going to be positive roots. Does that make sense there? Any questions? If so, hit the exclamation point. Otherwise, I'll put number 9 on the board. And then have you guys try that one. Yes, you have a question, or yes, everything's okay, Shelby? If you have a question, just hit the exclamation point so I know you're typing out a question. Okay. Yeah, so I'm assuming since there's no exclamation points, you guys are okay with that then. All right, so let me have you try number 9. Number 9, we have x to the 4th plus x to the 3rd plus x squared plus x plus 7. And so before you get going on this, because we have relatively few questions you guys asked about, let's make this the attendance question today. So again, you guys will put this in your ticket out the door notebook along with your ticket out the door problems. So go ahead and try this just like the last problem we did. Calculate how many possible positive roots, how many possible negative roots, and then based on that, what's the number of real roots that we could possibly have? Again, if you guys, when you get done, just go ahead and type done. If you have a question, just type the question as we're waiting here, and then I'll try to answer it as we go. Okay, Daryl, good. Is this one of your questions you had, Daryl? Did you get it now? Hopefully. Shelby? Oh, okay. Maybe 13. I think 13 was one year's. I couldn't remember if 8 and 9, if you had asked about that too. Yeah, mine too. I can't remember. I know the first class they just wanted 8 and 9, then you guys wanted 8, 9, and 13. So again, once you guys get done, just go ahead and type done so that I'm not wasting your time here sitting around. So then we'll work through this one. Everybody still working this? It's a little concerning if it's taking this long for this problem. So everybody's still working. Do you have questions on this or okay, Andrew? Well, since nobody's answering, I don't know, but let me go ahead and work this one. So for our positive, it's just the sign changes of what we're given. We start at positive and it never changes from positive. So for this problem, the number of possible positive roots is 0. For the negatives, I'm only changing the terms that have the odd exponent. So p of minus x is going to be x to the 4th minus x to the 3rd. Leave that one alone, x squared. Change this one. Leave the 7 alone. The constant never changes. So how many do we have here? The negative. I start positive, switches the negative, that's 1. Back to positive 2. Back to negative 3. Back to positive 4. So for the negative, it's either 4 or decreases by 2s. So 2 or 0. So therefore, the number of real solutions, I know it can't be 0. Well, it could be, but with the positive, that's not giving me any. So it has to be a negative, and it can only be 4, 2, or 0 if I end up having 0 negative roots. So that would be your answers for number 9. Any questions on that? Okay, so let's talk about section 3.5. So section 3.5, we start dealing with what is known as a complex number. So a complex number means that we have a real part, like our real numbers that we've been dealing up to this point, and then an imaginary part. And it has the form a plus bi. If I was to graph this, it graphs like X and Y, but instead the A is now my X-axis and the B is the vertical axis. And so the A is my real part. So we have part of the answer is real, and then part of the answer is imaginary. And so if, for example, let's say I have 2 plus 3i. So the real part here is 2. The imaginary part is positive 3. So when I'm talking about the imaginary part, I don't say 3i. The I is just indicating to me, hey, here's the imaginary part. But if you're telling someone, well, the imaginary part is positive 3, it just means that that's the imaginary. You don't say that, oh, it's plus 3i. So be careful with that when you're answering questions about what's the real and what's the imaginary part. Now, what is this imaginary part? What is this I? Well, I is equal to square root of -1. So up until right now, we've never been able to have a square root of a negative number. Now we can. I is square root of -1. If I square both sides, I squared is equal to what? I squared is equal to -1. Just square this side, you get I squared. Square this side, it takes out the square root. So I'm left with -1. And then the last tricky part of this then is dividing complex numbers. So again, let's say, for example, we'll use that same one, 2 plus 3i divided by 1 minus I. So if this says what's the real and what's the imaginary part, you don't just do, 2 over 1 is the real and 3 over -1 is the imaginary. That's not how that works. This whole thing is saying 2 plus 3i divided by 1 minus I. So you have to do this math first, then tell me what is the real and what is the imaginary part. And the way we do that to divide complex numbers is we multiply the numerator and denominator by the conjugate of the denominator. So just like when we were getting rid of radicals in the denominator, we multiplied by the conjugate, same thing here. So if I was actually figuring this out, I would have to multiply the top and bottom by 1 plus I and 1 plus I. Then go ahead, FOIL the numerator, that'll give you some answer. FOIL the denominator, that gives you another answer. Then you can tell me what is the real and what is the imaginary part. Does that make sense there? Any questions on that? Anything about the complex numbers there? All right. So the only question asked about in this section was number 13. And it was solve for x. We have x squared plus 9 is equal to 0. So we're going to solve this similarly to how we solved a simple quadratic. So we have to do what? We subtract 9 from both sides. So you get x squared is equal to -9. And then do what? We have to take the square root of both sides. And don't forget, it's plus or minus. When we're solving quadratics, we take the square root, we have to do plus or minus. So the left side becomes x, and this becomes plus or minus square root of -9. So this is a complex number, and using our radical rules, this is what? This is plus or minus square root of -1 times +9. So break this apart, plus or minus square root of -1 times square root of 9. Well, square root of -1 is I. Square root of 9 is 3. So this answer is plus or minus 3I. So if it wants it separately, you would probably enter minus 3I and positive 3I. I think it says put your answers with a comma or something like that. So that's how you would solve this one. Any questions on this problem? None? You guys are okay on it now? All right. So, because we got done so early, what I want to do, and so I'll start planning this for these next few classes, so that if we do get done early, then at least we're making use of our time. So I want to do a couple review questions. So we'll start going back. I'll start giving you guys some problems that you would see on exam 3 and on the final. I'll let you try and work them. Then we'll work them together. But at least it'll give you guys more review and keep some of these topics fresh in your memory still. So first one. So this is just review. This is not going to count for anything. You don't need it in the take it out the door notebook. None of that. So for this one, first thing we want to do is find the inverse of f of x is equal to x plus 1 over x minus 3. And B is state the inverse, state the range of the inverse in interval notation. So go ahead and try that one. Again, once you guys get done, just type done. So the inverse, this was section 2.7, I believe. So if you go back in your notes or back into your book, this would be 2.7. So this is what? This is a rational function. So it's like that 5 or 6 steps that I gave you guys. You just want to follow through those steps. Again, once you get done, just type done. And if you have a question, go ahead and type the question as well. And because we will have like time for this review as well, like if there's topics that you guys struggle with, and you want to see specific review problems, so maybe it's one like this, find the inverse of a rational function. Just shoot me an email. That way I know to make sure to include those when we do these little, 15, 20-minute review sessions that we have here available. Okay, Shelby? Anybody else still working? Need more time? Okay, Daryl? So again, similar to the ticket out the door problems, these review problems are problems you're going to see on the exam. So if you are struggling with these, yeah, that's fine. If you guys are struggling with these, go back to those sections. Like I said, I think this is 2.7. So go back to that section, try some of the problems out of the book. If you still need more examples, let me know. I can give you guys more examples here during these little review sessions. So yeah, we'll hold off for another minute or two here for everybody. All right, so I'm going to work this one. So actually, let's do B to begin with here. So the range of F inverse is what? It's just the domain of F. So really what question number 2 is saying, what is the domain of F? So how do we figure out domain of F? Well, we have a denominator. That can't be 0. So the range of F of X is equal to the domain of F of X, which in interval notation is just negative infinity up to 3 union 3 to infinity. So that one we can do without really even calculating the inverse at all, because it's knowing that the range of the inverse is the domain of the original. And the domain of the original is everything other than when the denominator is 0. So everything except for 3. So now for the inverse itself. So we do what? Y is equal to x plus 1 over x minus 3. And again, it's those 5 or 6 steps that I gave you guys. First thing we do, multiply both sides by the denominator. Next step, distribute the y. So now I'm going to work this twice here as I go. So depending which way you moved it, you'll see how you get your answer. So here, if I move all the x's to the left and the 3y over, you should have xy minus x equals 3y plus 1. So that's by moving all the x's to the left, everything else to the right. If you move the xy to the right, you're going to get x minus xy and move the 1 over minus 3y minus 1. So these are both the same answer. It's just that we moved the x's one way versus the other. Then what do we do? And so again, this is sort of two separate ways to work this problem. We factor out an x, so you get y minus 1. Factor out an x over here, you get 1 minus y. It's going to be reversed. And then divide by the y minus 1. So here, divide by the 1 minus y. And now that we have x by itself, change all the x's and y's. So in this case, f inverse is equal to 3x plus 1 over x minus 1. Over here, if I change them out, I have f inverse of x is equal to negative 3x minus 1 over 1 minus x. So either answer is acceptable. They are essentially the same answer. One is just a negative of the other. It just depends which way you move the x, whether you get this one or that one. So as long as you have either of these answers as your final answer, that's fine. That would be the correct answer. So any questions on this one? All right. So second example for you guys. So divide p of x is equal to 3x to the fourth minus x plus 1 by d of x, which is x minus 2. Part A asks, what is q of x? And part B says, what is r of x? So go ahead and try that one. Do the division. You can either do it long division or synthetic if synthetic will work. If synthetic doesn't work, or if you don't like synthetic, use long division. And then once you have your answer, what's q of x and what's r of x? And again, once you have this one, just type done. If you have a question, go ahead and type your question. All right, Shelby, leading the way here today. All right, Daryl, good. And Lee? All right, is everybody finishing up or still need a little more time yet? All right, Brianna? All right, so let me work on this one. So we can do this long division. We can also do this synthetic division because this is the form x minus c. So if I'm going to do synthetic, it's the opposite of what I see. I see -2, so I'm going to put +2 on the outside of my bracket here. And then inside are all the coefficients. So I start with 3, but I'm missing x to the third and x squared. So those have to be zeros. And then minus x and +1. And then whatever I end up in this bottom corner, that's my remainder. So then it's the synthetic process. Bring down the 3, multiply it as 6, bring it up here. Add these two is 6, multiply 12. Add these two is 12, multiply 24. Add these two is 23. 2 times 23 is 46. 46 plus 1 is 47. So the 47 is my R of x. The 3, 6, 12, 23, these are the coefficients of my variable terms. I started with x to the fourth, so my answer is going to start with x to the third, 1 degree less. So it's 3x to the third plus 6x squared plus 12x plus 23. So that should be your Q of x and your R of x. So any questions on either of those two answers? All right, so let me give you guys your ticket out the door for today. So number 1, find the roots of P of x is equal to 2x to the third minus 5x squared minus 6x plus 9. Number 2, solve for x. You have 2x squared plus 2x plus 1 is equal to 0. So go ahead and try those. When you guys get done again, if you want to plug in, you want to type in your answers, and let you know whether you have it right or not. And once a few people start getting it, I can post the answer on the board. So again, once you guys get done, if you want to type done or if you want to type in your actual answers, I can let you know if it's right or not. If so, you're free to go. I guess you're free to go anyways. Can't stop you from logging off. So. Everybody getting this? Have questions? Just working? And if you guys get the answers and you want to type them in, I can let you know if you have them right or not. I can post them on the board once a few people get them. Yep, Shelby, that's exactly right. So -3 halves, 1 and 3. How do we get -3 halves? Oh, halves, yeah. Did you get the other two, Randa? Did you get 1 and 3? Randa, did you get 1 and 3? You just didn't get -3 halves? Okay, so Branda, so it's still the same. So it's just now instead of ones as your coefficient with the 2, you're going to have 1 and 2 as the factors for the coefficient. So you're going to have 1 over 1, 3 over 1, 9 over 1, and then 1 over 2, 3 over 2, 9 over 2 as your possible answers or as your possible roots. No. So you're confusing problems here, I think. Yeah, because when you write it out, it's not going to be to the squared and to the fifth. So I think you're confusing this with graphing polynomials versus finding the roots. So just be careful with that. Shelby, yes, that's right. So for number 2, your answer is -1 plus or minus I over 2. Or if you break it apart, like Shelby has, -1/2 plus 1/2 I, -1/2 minus 1/2 I. No, that's okay. I just want to make sure that you don't cross them up on the exam. So just you want to follow through that process, whatever, like we were doing in the homework. Same thing. So these are both like homework problems from today. Finding the roots and then a complex solution. So just be careful that if you're trying to find the roots, that you're using those steps and not the multiplicity and stuff like that. Otherwise, that's going to get you messed up there. So. Okay. Everybody else have the answer? Having any issues? I see people dropping off. So. Well, since I guess you guys are all leaving, I will shut down the stream here. We'll see you guys on Wednesday. If you do have any questions, we still got a few more minutes. Just type in exclamation point. I'll hold on until you ask the question. Otherwise, I guess I will end the stream and then see you guys on Wednesday. Okay, so if no other questions, I will end the stream. Again, you guys have the answers here. So please do make sure you can work these. These types of questions will be on exam 3 and on the final. Otherwise, you guys have a good night. Stay safe. Hopefully we get to open up America soon. Yep. See you, Daryl. And we'll see you guys on Wednesday.